$200 million ship. How 10,000 workers build this? This 6-story building isn't a factory or workshop, but rather the engine of the world's largest LNG-based container ship. It's so large inside that workers can easily move around inside. This engine drives a propeller the height of a double-story house. And, of course, since it's a container ship engine, it must require a lot of fuel. But how much? It consumes 100,000 liters just during starting. Amazingly, its fuel tank can fit 6 Olympic-sized swimming pools, and it's fueled by 20 million liters of liquefied natural gas. Today, you'll learn about the construction of a mega project that literally challenged the limits of human engineering. Once again, the video from Udarajput official is a delight. Viewers, it's the 21st century, but 90% of international trade still happens by sea, whether it's something as small as a needle or the largest vehicle. To give you an idea of this, flight radar indicates that there are between 15 and 2,000 airplanes in the sky at any given time. And if we consider marine traffic, there are an astonishing 38,000 airplanes worldwide at the time this video was taken. Cargo ships are traveling. In terms of the size of these cargo ships, we humans already build the largest ships. Even larger ships can be built, but they won't be able to navigate major canals like the Suez and Panama canals. Therefore, the competition now isn't about building bigger ships, but about building more fuel-efficient ships. And that's exactly what the French shipping company, CMA CGM, did. They wanted to build the world's largest eco-friendly ship, which would run not on diesel or HSFO fuels, but on LNG, a liquid form of natural gas. This 400-meter-long ship is the same length as 4 football fields lined up. Its width is 61 meters, and its height is taller than the Qutb Minar. The ship's total weight is equivalent to 7 Eiffel Towers or 11,500 African elephants, that's 70 tons. This ship can fit a total of 2,312 containers. To imagine their size, if these containers were lined up in a row, they would form a 150-kilometer-long line. But the real challenge wasn't just building this massive ship. CMA CGM had to build 9 such ships, all within a span of just 2 years. A shipyard in Hong Kong was chosen, spanning 4 kilometers and resembling a small city. Here, 6,000 workers from around the world worked day and night, each assigned a specific task. But the question is, while a ship normally takes 18 months to complete, how will 9 ships be built in 2 years? The simple answer is that the ships will be built in pieces called blocks. The ship's foundation consists of steel sheets to prevent rust. 12,660 steel sheets were required for each ship. These sheets were cut with a special laser beam with a heat of 18,000 degrees Celsius, 3 times the surface temperature of the sun. This laser beam cuts steel like a knife through butter. A total of 880 kilometers of steel strips were cut for one ship. These sheets were then joined to form blocks. These blocks can range from the size of a single room to as tall as multi-story buildings. And the amazing thing is that these blocks already have pipes, wiring, and other fittings installed. This is the rear section of the ship, made from 5 blocks. It weighs 790 tons, equivalent to 2 train engines. It takes 2 people just to lift this section. Joint cans were used. These were placed onto the ship's existing hull with extremely fine precision, and remember, even a 1 mm error can ruin months of hard work. Once the blocks were in place, it was time for a never-ending series of welding. Astonishingly, a total of 1,250 kilometers of welding was done on this single ship. This means that if this welding were laid out in a line, it would start from Karachi and end in Lahore. After welding, each seam was meticulously checked. As the ruthless waves of the ocean do not forgive even the slightest weakness. So far, this was just the story of building the hull and blocks. The real wonder lies in its engine. This ship will not run on traditional oils or diesel fuel. It is designed to run on LNG, or liquefied natural gas. This is a huge environmental victory. Because LNG releases 99% less sulfur dioxide, 91% less air pollution, and 20% less carbon dioxide than oil. This is a major step toward cleaner sea travel. But if CMA and CGM are to revolutionize the shipping industry, they will have to pay a heavy price. The biggest issue here was storing LNG in liquid form. The fuel tank containing the LNG remains cool to -1 degree Celsius. If it gets hot or the fuel tank's insulation is poor, the LNG will expand into a gas, and that's it. This large ship must make the long journey from Asia to Europe without refueling. This requires a very large LNG fuel tank. But how large? Surprisingly, this is the largest LNG fuel tank to date, with a volume of 18,000 cubic meters. It's so large inside that it could fit 6 Olympic swimming pools. In total, it can hold approximately 20 million liters of LNG. But the real challenge isn't building such a large fuel tank inside the ship, but protecting it from heat. It's like building a combined thermos the size of 6 swimming pools inside the ship. It took the company approximately 9 months to build this fuel tank. The tank walls were coated with multiple layers of insulating materials, which protect the tank from external heat. Next comes the most crucial stage, leak testing. Because it's crucial for this tank to be airtight, the workers used a simple method. Soapy water was applied to the joints, and then a glass container was placed inside, and all the air was removed using a compressor. If the joint is weak, the vacuum will allow outside air to pass through, creating bubbles. Thus, leaky joints were identified and repaired. Applied. This is a special steel membrane, just 1.2 millimeters thin. When exposed to the cold LAG of -61 degrees, the steel shrinks. This wavy shape allows the steel to contract and expand without breaking. And you'll be surprised to know that this technology is also used in the space station. Finally, after 8 months of hard work, this masterpiece of technology, the world's largest thermos, was completed. Now let's move on to its engine. It is the world's largest natural gas-powered engine ever built. It is 20 meters high, equivalent to a 6-story building. Weighing over 2,000 tons, this engine produces 85,000 horsepower. It's so large that maintenance staff can even move around inside. Bringing this engine to the shipyard was a major challenge in itself. It was transported in 6 separate pieces. Its most crucial component is its crankshaft, the shaft that transmits the engine's power to the propeller. This crankshaft alone weighs 220 tons. A special remote-controlled platform with 140 wheels was used for transporting it. It was then installed with millimeter accuracy. This engine has 12 pistons, each 1 meter in diameter, and the crankshaft is attached to these pistons. This engine will drive a propeller mounted on the ship's aft side. This one-piece cast propeller weighs 92 tons and measures 10 meters, 33 feet, tall. The engine's power will be transferred to this propeller via a propeller shaft. It's crucial for this propeller shaft to be perfectly straight, as even the slightest sag will cause vibrations at high RPM. To verify this, a special blue dye is applied to the propeller shaft and fitted inside the propeller. Moved, it reveals which part of the shaft touches the inner surface of the propeller. This test shows engineering teams the areas where contact hasn't occurred and where pressure is high, and modifications are made accordingly. Once the ship's entire structure is complete, it's time to protect it from the ocean environment. That means painting it. Salty ocean water, waves, and friction can eat away at steel, and the rough surface increases fuel consumption. Therefore, a special paint is applied to the ship. Approximately 1 million liters of paint were used on one ship, and the total area was 9,500 square meters, which, in simple terms, is twice the area of Vatican City. Next, the tallest and final block, called the command bridge, was installed. This is the brain of the ship, from where the captain and crew control it. This 400-meter-long vessel is equipped with a system called Smart Eyes, which provides the captain with a 360-degree view from the bridge. Finally, after a year and a half of tireless work, the first ship, Jack Sedan, was ready. During 15 days of rigorous sea trials, every detail of the ship was tested. The engine was speed tested, the emergency brakes were tested, and the navigation systems were also tested. The entire structure was also checked for leaks. And most importantly, the anchor was deployed and tested. This joint beast's anchor, just one link of its chain, weighs 300 kilograms, and the entire chain weighs as much as 60 African elephants. Finally, the 15-day sea trials were successfully completed. The engineering team's goal of building low-carbon emission ships finally became a reality. The shipyard won the race against time. One after another, 9 such container ships broke records. It was completed within a short period of time. This story isn't about the creation of this mountain of steel, but rather the story of the ingenuity and day-to-day hard work of thousands of workers. These massive ships are now ready to rule the world's oceans, and in a much cleaner and more refined manner than before. These mega ships are proof that if a person sets his mind to something, he can make even mountains of steel move in the ruthless seas. We hope you'll like and share this Udarajput official video. Thank you so much for your loving comments. See you in the next amazing video.